In this example, we're given some information about the end behavior of the function, and we're asked to sketch a possible graph for the function. All right. Now, a couple of key things is that we're asked for a function. So this thing has to be a function, which means it must pass the vertical line test. It's easy to overlook that. So make sure that whatever you draw, make sure it passes the vertical line test, because we want a function, and we also want it to be defined for all values of x. So we don't want the function to have any vertical asymptotes or holes where it's not defined. So we want to make sure that that's the case as well. So, all right, we just want to sketch a graph. All right, so I'll just draw a set of axes here. Here's my x-axis. Here's my y-axis. I'm going to say y is equal to f. I guess it says it. Y is equal to f of x. So, all right. So in this first case, we've got x as x approaches infinity, f of x approaches 3. So what I want to do, so that's telling me that I have a horizontal asymptote at y equals 3. Right? I have a vertical asymptote because I have the end behavior as x approaches positive infinity is 3. So that gives me a vertical asymptote. And then as x approaches negative infinity, f of x approaches negative infinity. All right, so it's going down in this direction as x approaches negative infinity, and as x approaches positive infinity, it's approaching this line. Now it could be approaching from either direction, right? We don't know if it's approaching from above or below. So there's more than one answer to this question. Now, probably the simplest thing I could do would just be to draw sort of a function that looks like that, right? That would be a function that approaches negative infinity as x goes to negative infinity, and it approaches 3 as x approaches positive infinity. So, but like I said, there are other answers. So for another case would be, well, maybe it comes up and then it comes back down like that. You could have a case like that. That would also, a function can cross its asymptote. So you could have a function like that, and it would be, it would satisfy those criteria that were given. All right, so let's look at the next one. So again, I'm going to just start with coordinate axes here, x and y. And now we're told that as x approaches positive infinity, f of x is approaching pi over 2. All right, so I'm just pi over 2 is like, well, 3.14 divided by 2. So it doesn't really matter. I don't have a scale on here, so I'm just going to say this is the line y equals pi over 2. Right? That's this end behavior is telling me that I have an asymptote at y equals pi over 2. All right. So that's one asymptote. And when x approaches negative infinity, it approaches negative pi over 2. So let's draw another asymptote. I'm just going to draw a dotted line to represent the asymptote. This is the line y equals negative pi over 2. All right, so as x approaches positive infinity, the asymptote is pi over 2. So it's going to approach like that. Down here, as x approaches negative infinity, it approaches negative pi over 2. So, so one possible function would be, just something that goes like that, right? We could have a function that looks like that. And, this is a case where you don't, it's only defined between pi over 2 and negative pi over 2. Now, it doesn't have to, there could be other cases where, you have something that comes up and then back down like that. You could have other, or it could even, let's see, maybe you should do a different color. We could even have something that goes up and then back down and then comes back up like that. So as long as it's a function, right? So it has to pass the vertical line test. And it's defined for all values of x, right? So we don't have any holes or horizontal asymptotes. All right, let's see. I guess that's all I've got for you, and I'll meet you in class.